What happens here is that in computer science we differentiate between two kinds of informations. On the one hand, we have numeric information, and on the other hand, we have alphanumeric information. The first one is used for computing, making operation with numbers, and the second one is for displaying information. With a numeric representation, that's what we have seen before. We can work with natural numbers, integers. We can work with real numbers, but in fact, it's not real numbers. It's fractionary numbers, but in our case, it's more or less the same. And with numbers, we have a representation that is useful for operate with them. For example, if easy to add two numbers in this representation. 1 plus 2 is 3. It has a representation that is easy. It's very easy to operate with it for floating operation, everything. But we have a representation used for making operation, multiply, add, subtract, exponentiate, whatever. The purpose of alphanumeric information is visualization. We are not adding to numbers. In alphanumerics, I've been working with numbers, but this is a text editor. We can write not only numbers, but I can write a text here. Okay, that's the trick. And if I have a text, I can't perform operation with text. I can add 5 to a text. I can multiply by 3. I can't raise to the third power. Those are operations that we use on numbers. For alphanumeric information, we have a completely different set of operations. And we can see it if we open a programming language. For example, I am going to open Python, and I will show you how the different operations we can have with numeric and alphanumeric numbers. For example, if we write a 2 here, this is a number. We can, for example, add 5 and we have a 7. But usually in programming languages, we use quotes to represent alphanumeric information. For example, if I have a 2 and I add a 5, I have a 25. Why? Because the operation is different. When we're visualizing something, we want to concatenate the information, the strings. It's a different operation. We can, for example, we can multiply 2 by 5, but we cannot multiply a 2 by a 5 because it can't be another character. It doesn't need to be a number. We can have here patata by 5. It makes no sense. In some cases, programming languages offer some operations mixing alphanumeric and numeric information. For example, patata by 2 will be patata, and they have some special operators that only work on numbers. For example, I can have a subset of this string, and with this I'm telling Python to get the first 2 characters from the string, but it's not something that I can do with a number. For example, if I have 1, 2, 3, 4, 5, 0, 2, that's not gonna work. Okay, I have an error here. So 2 different kind of operations, numeric and alphanumeric. 2 different uses of that information, operate and visualization, and different representation. A 2 here is not represented the same way as a 2, an alphanumeric 2. Okay, they have different representation on this. We have seen before, and it's difficult to differentiate. If we have a file, for example, it's difficult to tell which kind of information we have because in the end, this is an stream of bits and this is another stream of bits. So sometimes it's different. It's difficult to see if we are to tell if we are looking at numeric information or alphanumeric information. It's some way tricky, but we will see in the videos, in the next videos, how alphanumeric information is represented and how we can distinguish it from numeric information.